Hello everyone. Today I'm going to guide you through another example of method of fragment. So in this example, I will do the same questions with the flow net. But with the method of fragment, I divide the foundation into three parts, 1, 2, 3, and then I define the fragment type of each part. So fragment 1 and 3 will be of type 2, and fragment 2 will be of type 4. And now I calculate Phi for each fragment. For fragment 1, I use coefficient m, which is sin of pi s divided on 2t, where t is thickness, and s is the depth of the seed pi. So it is given is 9.4, and I get m is 0.75, and I get the m square is 0.57, and I calculate phi 1 from the table. As you can see from here, the value on the left column ended as 0.5, so therefore I have to look for the value in the right column. I go up to get the value of phi I in the second column from the right is 1.07. Or I can calculate it with the given graph. So I calculate S on T first, which is 9.4 on 17.2, and I know that my B on S is 0, B on T is 0, so therefore I look up this value for the top line and I calculate back to get my phi 1 is 1.06, which is very close to our table. For fragment 2, which is of type 4, I have to define S and L first to compare this value. I have S is 9.4 minus 1.6 because of the depth of the foundations, which is 7.8 meter, and L is 50 meter is given. So from here, I can get the phi 2 by the approximate equation. And the value for phi 2 is 3.4. For fragment 3 of type 2, I do the same like I did for fragment number 1. And I look up this value again in the given table. So now I can use the left column because the value of m squared is small. And I got this number is 0.471. So after calculated phi I for each fragment, I calculate the discharge by the main equation. And K is given. Delta H is the difference of the total head from the upstream to the downstream, which is 6.3, and phi I is they are all calculated before. So I get it will be 5.86 10 minus 6 meters square per second. And it is smaller but in the same range with the answer from the method of flow net. For the uplift distribution, I have to calculate the H loss in each fragment by the given equation. That phi I times by sum of delta H, which is 6.3, divide on sum of phi I, which is calculated before. And I get delta Hi for each fragment. And then I go from the upstream water level, go down by delta H1. And for the length of the dam, I go down for delta H2. And for the acid fragment, I go down by delta H3. For the acid gradient, I have to use the graph, and I look for the value of S on T, which is about 0.09, and then I go up to get the value of I acid times by S divided on He.